Now, what is a parametric function of a unit circle? Well, allow me to explain. In a previous video, I covered parametric functions and Bezier curves, but I didn't do a very good job. So I'm going to try to do a much better job today than I did in the previous video. Okay. First of all, what is a unit circle? Well, this is a unit circle. The unique part of a unit circle is that its radius is 1. Okay. So, if the radius of this circle is 1, then what is a radian? Okay. The length of this line is the length of pi, which is 3.14 whatever number. Okay? And I'm sure you remember this from your early days of early algebra, possibly even elementary mathematics. They covered that the length of the diameter here is 3.14 and whatever. Okay. Now, we know that if you go from this point here to this point here, you will cover 180 degrees. So, if you have pi times a radian, you're going to have 180 degrees. If that being the case, then if you divide both sides by pi, there, then a radian, 1 radian would equal 180 degrees divided by pi. So far, so good. I think you can get this. Alright? Now, the approximate number of this, and I mean approximate, is 57. 57 degrees. 1 radian equals 57 degrees approximately. Now, you have a radian, or you have a radius, which is 1. Okay? Now, the radian is going to be the length of this. Now, the length of this is supposed to be the length of this. Okay? So, if you have 1 radian, okay, then this angle right here is going to be 57 degrees, approximately. Okay? So the length of this is supposed to match the length of this, which is 1. And that's where you get your radian. Now there's a little problem with all this. Okay? And that's because you have this thing called the Cartesian coordinate system. I have covered this with René Descartes. Now you say, well, what's the big problem here with this? Alright, you have, if you're going to draw this out non-geometrically, now if you're going to draw this out geometrically, you don't have to know much else than what I've already told you. But if you're going to draw this out in a non-geometric format, if you're going to actually graph this on the Cartesian coordinate system, then you have to have the x and y coordinates. Well, the x and y coordinates cannot be represented by a radian. It can't. So you have to find the numerical representation for the x and y coordinates of this radian. How are you going to do that? Well, what you have to do is you have to say that t represents the radian. What you're going to do is you're going to find the cosine of t, and that's going to be the x-coordinate, because x represents the cosine of t, and then the y-coordinate represents the sine of t. Okay? Now then, here comes the mighty problem. obviously t is going to change as you go around and around and around the circle. Okay? You're eventually going to have a little over 6 radians in this circle. That's what you're going to have, because you're going to have 6 angles of 57 degrees plus a little bit more. Because 57 times 6 is not a full 360 degrees. So, what you're going to have is you're going to have a function. And x is going to represent the function of the cosine of t. Now, what is a function? Well, let me give you a really silly but basic explanation. When you have the equation 3 plus 5, you get 8. If you add the numbers 3 and 5 together, you're not going to get anything other than 8. I don't care what some math teachers tell you, you're not going to get it. Alright? If they tell you you're going to get anything else other than 8, don't listen to them. Stay away from them. They're bad news. Okay? So anyway, 3 plus 5 equals 8, and only 8. And that's what it means. Okay? So, actually what you can say, let's say we have, that's a plus sign there. I know it's really ugly. Let's try this again. We can actually say 3 plus x equals 8. So the f of x is 8. Okay? So all I have to do is find out what x is, which x is 5. So the function of 5 in this equation is going to be eventually 8. Alright, and that's what we mean by a function. No matter what value you put as x, the final answer that you'll get is 8, and only 8. Okay? And so you could have a very weirdo equation. I'm not going to get into this today because I have actually covered functions more than once on my YouTube channel, and you probably know what they are by now, and if you don't, you should. Okay? Before you ever get to this video, you should know, and you should look up through my mathematics video. I have at least one playlist, if I don't have 2 right now, of mathematics videos, and around there you're going to find a video about functions, and you'll understand that a lot better. Okay? So, sine, cosine, and tangent in this particular case are going to be functions. Okay? And so you're going to use those functions to find the coordinates of x and y to plot your point on the Cartesian coordinate system to do this, to actually draw this for a unit circle. Okay, so as the t value changes, the x and y coordinates are also going to change. That's why they call it a parametric function. You're actually inserting the value of a third function into these two. Okay? So you're going to have 3 sets of values, but only an x and y at the end. Okay? So what does x represent? It represents the cosine of t. What does y represent? The sine of t. So as t increases, the values of x and y are either going to increase or decrease. In this particular case, as you start going up like this, the values of y will increase, but the values of x will decrease. Okay? Now, as you get closer down in this area, the values of x, well, now see, if you go into this area, the values of x and y are going to decrease. You go down this area, and the values of x are going to increase, but the values of y are going to continue to decrease. And then if you go up this way, the values of x and y are both going to increase based on this. Okay? Now remember, as you travel along this circle, the radian value, this t here, the radian value, will increase. So you'll have 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, and 6 radians. But even though the radian value increases, the x and y values will vary. Sometimes y will increase, sometimes x will increase, sometimes y will decrease, and sometimes x will decrease. And it will all be based on the t. This is going to go up no matter what, but these two may go up or down depending on what position they are on the circle. And that's why you have to have a parametric function. Because you're measuring by radians, you still got to plot those x and y coordinates. And how are you going to get that? That's how you're going to get it. And that's the parametric function of a unit circle. Now do you see why Bezier curves are so important? Alright. Well, I want to thank you very much for watching this particular presentation. I will tell you more in a future video, so I'd like for you to stay tuned.